Hello everyone, welcome to day 5. We are going to be going over indeterminate forms and L'Hospital's rule. In this section, we learn a new method for finding limits. When you have this form of a function over another function, and either the limit of both of these functions approach 0, or both of the functions approach infinity. So for example, if f of x, the limit of this function up here approached 0, and g of x 0, so 0 over 0 form, or if f of x approaches infinity and g of x positive or negative, then we know we could use L'Hospital's rule. And the other thing is that they both need to be differentiable on an interval I that contains a value a, except possibly at a. So when you have this form, you're able to find the derivative of each of these functions and then get the limit as x approaches that same value a. And then we also learn how to work with indeterminate products. So that's when you have the limit of two different functions and where one of them approaches 0 and the other approaches positive or negative infinity. So in this form, right? And when this happens, you are able to change, see how they're being multiplied? You could just divide by the reciprocal, kind of going backwards from, multiplying is just dividing is just multiplying by the reciprocal. So here you just put the invisible 1, right, under g. You just flip it over to put it in this form. And you could do it for either the g function or the f function. Okay, so let's jump into some practice problems. Let's see what happens when we find the limit for each of these. So for number 1, we're finding the limit as x approaches 5 of this function here. So you could think of the top as f of x and the bottom as g of x. So as x approaches 5 here, 5 minus 5 is 0. X squared, 5 squared minus 25. So 25 minus 25 is 0. So you could see we have the 0 over 0 form. So we could use L'Hospital's rule. So then I'm going to get the derivative of each. Okay, so then the derivative of, I'm just going to write, to just track what I'm doing. So the derivative of the top is just 1, right? And then the derivative of the bottom is going to be 2x. And now let's get the limit as x approaches 5. So then the top is just going to be 1, and the bottom is going to be 2 times 5, and that is 10. So that is your answer. Now let's try the next one. So the limit as x approaches 0, here, this is going to be 0. So tangent of 0, if you remember, tan is sine over cosine, and sine 0 is 0, right? So 0 over 1 is 0. And then sine 0 here, the same thing. This is going to approach 0. Sine 0 is 0. So you could see we have the 0 over 0 form. And now we could use L'Hospital's rule. And this is going to be getting the derivative of each of these functions. So the derivative of tangent is secant squared, 5x. And then we do need to use the chain rule. So the derivative of 5x is 5. And then in the bottom we have sine. The derivative of sine is cosine, 6x. And then using chain rule is times 6. Let's go over here. And so I'm going to move the 5 in the front. And then we write limit as x approaches 0. 5 times secant squared 5x over 6 times cosine 6x. Okay, and we know secant is 1 over cosine, right? Equals 1 over cosine x. So as x approaches 0 here, this is going to be 0, and cosine 0 is 1, so this is 1 over 1. So this is going to be 5 times 1 over cosine 0, the same thing here. We know cosine 0 is 1. So that's going to be 6 times 1. And then our answer is 5 over 6. Okay, so now we're going to do the next one. The limit as x approaches 0 of cotangent 2x times sine 6x. And we know cotangent is cosine over sine. And as x approaches 0 here, this is going to be 0. And we know cosine 0 is 1 over 0. So this is undefined. And we know by the graph that this is going to be approaching either positive or negative infinity. Okay. And then sine 0 is 0. So now we notice that we have this indeterminate form, product, right? Okay, so for this one, I'm going to write, so this could be f and this is g. And I'm going to use, we're going to put sine 6x on the top. And then I could put 1 over f, which is cotan 2x. And 1 over cotan is just tangent. Okay. Oh, 0 as x approaches 0. So as x approaches 0 here, sine of 0 is 0. And then tangent we know is sine over cosine, so it's 0 over 1. So this is going to be 0. And now we could use the L'Hospital's rule and get the derivative of each. So the derivative of sine is cosine. And then using chain rule, we know this is going to be 6. And then the derivative of tangent is secant squared times 2. Okay, and then now, as x approaches 0 here, this is 1 times 6. Cosine of 0 is 1, so that's 1 times 6. Secant is just 1 over cosine, so that's 1 over 1, which is 1, right? Because cosine at 0 is 1, times 2. Okay, and now we just simplify, and then we get 6 divided by 2 is 3. Okay, now for the next one, as t approaches 0 here, e to the power of 0 is 1. Anything to the power of 0 is 1, so it's going to be 1 minus 1. And then sine 0 is 0, so we get 0 over 0. And so now we're going to use L'Hospital's rule. And so the derivative of the top, let me just write limit as t approaches 0. Remember, e to the u, which is, we could consider this u, is just itself times the derivative of this here, which is 5. And then the derivative of sine is cosine. And now here I'm going to move the 5 to the front. E to the 5t over cosine t. So here as t approaches 0, e to the power of 0 is 1. Cosine 0 is 1, so this is equal to 1, and then times 5 is equal to 5. Okay, and that's about it for today. I'll see you all tomorrow. We are going to be going over integration by parts.